Hey guys, it's Dane the Portable Ham over here at Halibut Electronics. What do you guys got going on today?
Well, I'm going to show you the common mode current choke test rig. So when you are measuring, let's not use that one because my VNA is not actually calibrated yet. When you're building a choke, common mode current choke, something that you would put at the feed point of your antenna or at the feed point of your radio to kind of lower the noise floor, or if you start getting RF in the shack or a hot mic or whatever, that's because you've got common mode currents somewhere in your shack, and you want to be able to get rid of those. So you build what's called a choke to eliminate those currents. And I'm summarizing a whole lot of physics here, but the thing is that those chokes are operating on the outside of the coax, or that's Ethernet cable, but same thing applies. It operates on the outside of the coax. It is common mode, whereas all of the other signals, such as what a VNA measures, are differential mode, which is on the inside of the coax, right? So it's difficult to get a VNA to measure the common mode of a device because you have to get the signal from the inside of the coax to the outside of the coax, run it through your device that you're measuring, and then put it back on the inside of the coax to the VNA to be measured. So that's what these do.
Okay.
It's a device that lets you measure the common mode of a choke or some other device. And so it takes a signal from the inside, sticks it on the shield, you connect your choke up to this, it measures the choke and then sends it back in it runs it through the choke, then sends it back into the VNA to be measured.
Oh, nice.
So if you're deploying a choke somewhere in your shack and you want to measure how good it is, or more importantly, let's say you build a device and it doesn't quite work, so you need to fiddle with it and tweak it to improve it. Well, if you made a change to that choke, how do you know if it improved it or made it worse or anything else, right?
Yeah.
Because they're so difficult to measure, you don't know that. It's not an obvious intuitive thing. And so these allow you to actually measure that device.
Cool. That's super awesome.
Yeah.
So we can actually see if we're actually improving
Correct.
our situation over than just like, hey, let's hope this works.
Exactly.
I'm not gonna lie, I might have done that a time or two of like, hey, if I just throw a whole bunch of chokes on this, is it gonna help?
Yeah, and I'm not gonna talk smack, because if that's all you've got, then do it, right? Get on the air. None of this is gonna say like, oh, well, that's not good enough, right? This is just gonna tell you how well it's working and what you can change, or when you make a change, whether it improved it or not, right? That doesn't mean, oh, this isn't good enough, don't bother getting on the air. Never. Like, always get on the air. Right, it'll be better than not getting on the air. Let's put it that way, right? So we have the RF version with a bunch of coax connectors. All the different connectors are just there because chokes come with different connectors, and I don't know what kind of connector your choke's going to have.
Yeah.
So this allows you to measure them all. But I've recently released what I call the digital common mode current choke test rig. It's the exact same thing as the RF version, but it has Ethernet cables, Anderson power pole, 3.5 millimeter audio sockets, and all the various different USBs. So if you're starting to get RF on your Ethernet cables, your network cables in the shack, and you need to build a choke on there, now you can measure that choke as well.
Awesome. Well, hey, thank you very much for your time, man. I do appreciate you.
Absolutely, I appreciate you. Thank you.
All right, man, thanks.